So far we have learned what is potential. Now how it is connected to potential energy. Let me give you an example for this. Let's say we have a spring. Okay. Now the spring in a normal condition. It is not elongated, not stretched, not compressed. Okay, so there is no energy stored here so far. Now, whenever I am compressing the spring into a new position, so this is another condition for the spring. I have compressed to this position. So it will have certain energy at this position. Clear? Now I am compressing into a next position. So we know that as we are compressing it from the mean position inwards, more compression we make, more amount of energy will be stored. But how this energy will be delivered? See, the moment you withdraw this point will go back to the mean position. But has the energy been given to an object? No, right? So this position represents the potential. Okay, it has potential. For example, I'll take different example. We have, for a bookstore, I could say that any position very near to school is a potential market, because they can expect a lot of students coming into their store and buying materials, book or pen from their store. But it's a potential market, right? But unless and until a store is opened and commodities are displayed, we can't expect sale. So similarly, potential is the property of a point. Okay, whenever items are displaced, commodities are displaced, then only we can expect sale or we can expect return from that business. So similarly, here in this case of spring, this is the position and this is compressed. It has potential now. It has potential down. Now when I am placing a mass here, now the moment you release it, or even when you are placing in this way, the mass now has got some energy. What is that energy? Potential energy. How come we know that? The moment you release it, this mass will be going to the other side with the energy that has received from this position. Similarly, with an energy that has received from this position, it can go to the other side. And see, in the case of electrostatic potential, I can give you one more example. Let's say we have a battery. The potential is 5 volt. But when I am placing a battery in this way, is it doing any work? Does it have any energy? No. Because this potential, only when given to a charge, that carries energy. Similarly, here it is given to mass and that is carrying energy. Similarly, when a battery is connected in this way, when there is no bulb across or when is no elements connected across, it cannot provide any energy. It has potential, but it is not doing any work. Now, how can we put this battery into work? By connecting a bulb like this. So what will happen? Now it is connected with a charge. Okay. Now this charge, this one terminal of the battery will be giving certain energy to a charge, and now this charge will start moving from this side and will go to another side. What is the inference from this? Only charges do carry energy. Potential is the property at a position. Okay, so different position in electric field will have different potential. But to get the value of potential energy, we need an actual charge at that position. Similarly, a mass connected here and another bullet or mass connected here, we need energy. We need material. So here in this case, electrostatics, we need charges. Now see, we have a source charge of Q here and the potential at this position, let's say at a RA distance away from the source charge. What is the value? Q by 4 pi epsilon 0 into 1 by RA. So that is the potential at this position. How do we get the value of potential energy? Multiply this with Q. When will this happen? Whenever I am bringing a charge, from infinity to here. I will repeat the concept again. Okay. Now, what do we mean by potential? Electrostatic potential at a position. Electrostatic potential is nothing but work done in bringing one positive charge from infinity to this position. Clear? Okay, this is just a test charge. This is just a standard defined. So we are not actually bringing unit charge here. This, we have defined the equations in this way. That is work done in bringing one positive charge from infinity till here. So far there is no charge here. So electrostatic potential at this position, just to define the term, we have defined it with the help of unit charge. So we can find, though there is no charge here, not even one positive or two positive, we can find the potential at this position. What will be that value? Q by 4 pi epsilon 0 into 1 by R, this one. So Rp. So here in this case, if this is x distance away, the value will be Q by 4 pi epsilon 0 into 1 by Rx. Okay. Now whenever I am bringing a Q charge from infinity to this position, and I am going to find the value of the energy stored in that Q, I can find the value of potential energy stored in that charge. Let me explain it to you again. Now how this potential energy has been stored? See, I have a charge of Q here. Okay. Now to move this object, to the charge from this position to this position, I have to do work, right? Okay, my hand have to do work. So let's say I have some energy. I am pushing the charge from this position till here. Why should I push? I'll make the source charge here. The electric field is in this direction. Now it is experiencing a force in this direction, QE. Now I have to overcome this force and I have to push the charge from this to here, then here, then here, then here, then here. So I am basically doing a work, right? So when I am doing work, my energy is decreasing. Let's say while me taking the charge from here till here, the charge has taken 100 joules from my hand. Okay. In that process, where does that 100 joules goes to? It will be stored as the potential energy of this charge. So for example, when I have a total charge of energy of 100 joules. Out of that, I have spent 20 joule in bringing the charge from infinity to this position. 20 joule I have spent. Okay, what is remaining with me? 80 joule. Now where this 20 joule has gone to? We have learned energy conservation. Energy can neither be created nor be destroyed. Now the energy in my hand, the 20 joule from 100 have been stored as the potential energy in that charge. Clear? Now simply potential energy is nothing but work done. Clear? Work done will be converted as potential energy. Okay, so far we have learned the equation V in between. So here in this case we are taking it from infinity. So potential at a point is nothing but work done in bringing a charge from infinity, that is one positive charge from infinity to a point A. Correct? Now the value is equal to work done in bringing a Q charge from infinity to A divided by Q. So this will be nothing, this is nothing but work done in bringing unit positive charge from infinity to this position. Now I have told you what is potential energy. Potential energy is simply work done. So whatever work we are doing, that will be stored as the potential energy in this charge. Now how can we get the value of work done from this? Work done is equal to multiply this. WA infinity is equal to VA infinity into Q. So this is a very important definition. I can, I mean, without A infinity and A infinity, I can, simplify this term as W is equal to V into Q, or W is equal to QV. You can memorize in this way. W is equal to QV. That is the work done for bringing a charge of Q from infinity to a position, any position. Here in this case, it is A. So in any position, to any position when we are doing work, what we have to do, to any position when we are bringing a charge, to get the value of work done, just multiply the charge with the potential of that point where we have dropped the charge. If we are dropping the charge here, then multiply with the potential at this position. This V will be potential at this position. Now when we are dropping at this position, this V will be potential at this position. Now this work done will be nothing but will be stored as potential energy U. Clear? Both are the same. Now to get the potential energy of a charge, what equation we should follow? Potential energy is equal to Q into V. That is the value of energy a charge carries when it is placed in a position in electric field. So in electric field, it will have a potential. Okay, when we are placing a charge in a potential, electrostatic potential, it carries some energy that is due to its position. It's not moving, right? The position, whenever I am just placing a charge of Q here, it has some energy. That energy is by virtue of its position, right? So that is potential energy. And how did it got the energy? When we are bringing the charge from one position, that is from infinity till here, whatever the work we have done, that is stored as potential energy at this position, and the value is equal to Q into potential at that point. Clear? Thank you.